Am I audible? If I'm audible, please write yes. Hello, Aditya. Good afternoon, Piyush. Am I audible? Yes. Zed, I'm audible. Thank you, Piyush. Let us begin with our unit, that is unit number 1, energy and environment. I'm sharing the screen right now. I hope you can see the screen. Yes, yes, you can see the screen. Let us continue with the next part of unit number 1. That is, yes, you can see. Okay, fine. Let me continue with the unit. Let us begin with our first unit, part 3. That is, the name of the unit is Basics of Energy and Solid Fuel. Okay, so it will be our third lecture on this. So, to begin with, today we are going to study on boys calorimeter. We'll study the boys calorimeter in detail. Okay. Let us continue. As I have told you earlier, there are 3 course objectives for semester 1 for the subject energy and environment. So you should know there are at least 3 objectives given by RTA. When you repeating this again and again, then we have 6 course outcome for 6 different units. Again, it has been prescribed by the university. Okay. So for this unit, for this unit, course outcome 1 will be taken into consideration. Let us just have a brief knowledge about the content. So these are the content of unit number 1. Okay. So here the things which has been highlighted with the red color is being done by me in the previous classes. Today we are going to do the Boy's calorimeter, that is determination of calorific by Boy's calorimeter. Okay. So to completing unit number 1, student will be able to obtain the knowledge of solid and gaseous fuel and their calorific value determination. Let us go with the term Boy's calorimeter. I have defined the word calorimeter in the previous class. It is nothing but an instrument with which we find out the calorific value of a given fuel or any substance which in combustion produces calories. So where we are going to use the Boy's calorimeter? We are going to use the Boy's calorimeter for gaseous or volatile liquid fuel. Okay. In the previous class, we have studied about bomb calorimeter. So where it was used? It was used to calculate the calorific value of solid fuel and liquid non-volatile fuel. So there is a difference in bomb calorimeter and Boy's calorimeter. So after giving you the sample of fuel, after finding out the sample or the type or the property of fuel, you are going to decide which calorimeter has to be used. Am I clear? If I'm clear, put yes in the chat box. Yes, anyone? Yes, ma'am. Bilal is saying ki, yes, it is clear. Okay, Mitali, Ruchika. Okay, thank you so much. So let us proceed further. Now let us go with the principle. What is the principle of Boy's calorimeter? The calorific value of gaseous fuel or volatile liquid fuel, ठीक है, is being determined by burning a known volume or sample of the fuel in a combustion chamber. Heat which has been released after the complete combustion is being absorbed by the cooling water, which is being circulated through the copper coils surrounding the combustion chamber. Okay. The mass of the cooling water and its rise in temperature has been noted, and the mass of the water which has been produced after the condensation of steam is also been recorded. Okay, and the calorific value of the gas sample is then being calculated from the data which has been collected. Clear to you? I'm repeating. What we need to do here is we are interested in finding out the calorific value. Which calorific value? The gross calorific value and the net calorific value. Okay, I have told you the definition of gross calorific value and net calorific value in lecture number 1. Clear? So what we are going to do here is we are going to burn the fuel in a combustion chamber. The amount of fuel burnt will be known to us. After burning the fuel, whatever energy is being released, it is being absorbed by water. We are going to find the temperature of the water then, right? And after combustion, whatever byproduct, especially the hydrogen on combustion produces what? Water. So after combustion, if hydrogen was there in the fuel, it will get converted into water. So the water will be condensed. So we are going to find out the amount of water which is being condensed. Okay, the mass of the water will be which is being condensed. It is being calculated. Okay, and from all these data, we are going to find out the calorific value of the fuel. Now here I have written gas sample. So it can be any fuel. I have told you earlier also the fuel sample can be from gaseous side or it can be liquid fuel which is volatile in nature or which gets converted into vapors easily. For example, just quoting an example here, for example, acetone, right? Alcohol, because when you keep it open, it get vaporized. Okay, so that was the principle. Now see the construction. I'm just going to read the construction part right now, and from the diagram I'm going to repeat the construction and the working simultaneously. Clear? Now before starting with the construction, I'm being given two sections here, and what I can see is only 54 students are being present from out of two sections. So I'm having roughly 110 students with me. I wanted the attendance. Now I'm being going bit strict here. I'll be sharing the feedback link with you in the WhatsApp group as well. And the feedback link will be open only for 5 minutes, 5 to 10 minutes. Whoever gives, whoever attend the lecture, okay, fine. You may give the attendance there in the chat box, but I'll consider the attendance of what? The Google form. Clear? Because I don't want 56 student here. I wanted all the 100 student to be present here. Now let us go with the construction part. It consists of a suitable gas burner in which a known volume of gas or of fuel is being burnt at a uniform rate. Around the burner, there is a chimney or combustion chamber having copper tubings coiled inside as well as outside. Water at a constant rate enters at the top of the outer coil, moves to the bottom of the chimney, and then goes up through the inner coil to the exist to the exit at the top. There are two thermometers, T1 and T2, which gives the temperature of incoming and outgoing water respectively. The whole assembly is being enclosed in an insulated chamber. During the process of down and up movement through the coil, the flowing water takes away practically all the heat of the burner, and any steam which has been formed during combustion is being condensed and it is being collected at the base in the tray. The thermometer T1 and T2 gives the temperature of the incoming and the outgoing water respectively. The whole assembly is being enclosed in an insulated chamber. Okay. During the process of up and down, the flowing water basically, again, I'm repeating the words here. It is being collected at the base, okay, in a tray diagram. Now let me explain in a very simple and in a very simple words, or you can say in a simple language to you, dear student. This is the structure of a Boy's calorimeter. Now, can you see these? This is nothing but a stand from where two burners are being placed, which is being used for burning the gas. So we are taking a special type of, you can say, base or a foundation or an area from where the burning will take place. And earlier we took a pellet sample or sample of coal, but here since we are using gas or liquid, so we need to have burner for burning. So we have two burners here, which is being attached to the gas inlet, in which a meter is being installed with a thermometer. Okay, this has been done in order to find out the rate at which the gas has been passing, or the amount of gas which has been passed into the calorimeter. Okay, why we have been finding why we have been using thermometer here, just in case if there is any change in the temperature, so that will help us in finding out the temperature of the gas. So this should also be the same as of the inside chamber temperature. Okay. Above this burner, there is a chimney which is being placed. Take a chimney. Okay. And above that, you can see a hood-like structure which is been covering the chimney. Both the chimney and the hood-like structure is been wounded with copper tubings. ओके कंटिन्यूसली इसको पूरा वाउंड किया गया है विद द हेल्प ऑफ कॉपर ट्यूबिंग्स पूरा कवर्ड है so we have one inlet and one outlet of the copper tubing. So this is the inlet of copper tubing and this one is the outlet of the copper tubing. Okay, complete wounding, right? Okay, so for the inlet and for the outlet, we are been placing two thermometers here for inlet water and for the outlet water. Two thermometers so that we can find out the temperature of the inlet and outlet. Below the chimney, there is a tray which is being placed here, and the tray is being joined outside with a beaker. Okay, whole of this assembly is being made insulated so that there is no exchange of heat either from outside to inside or from inside to outside. Okay, and there is a valve, or you can say an opening, which is being given in order to allow the exhaust gases or the waste gases to escape into the environment. Am I clear with the explanation of the diagram? If yes, type in the live chat box. Yes, anyone? Ashar says, okay, Ashar, Ruchika, thank you. Okay, shall I, I'm continuing with the working part of it. What we are going to do. What we'll do, we'll start with, we'll first remove the tray. We are going to clean it. We are going to make the tray absolutely dry. Okay, fine. We're going to place the tray back. Everything again is become, we'll arrange everything back to its position. Will allow a specific quantity of water to start flowing from inlet, and it will circulate into the hood and into the chimney part. It is going to come out. So the same amount of water is being circulated again and again. Okay, inlet water and outlet water. So for example, if I take 25 kg of water, so the 25 kg of water will be coming inside the chamber. It will be circulated and it will come out, and this procedure is being repeated till both the thermometers, that is T1 and T2 thermometers, give the same temperature. Agreed? Yes? Okay. So when the thermometer tells us about, or when we see the same temperature is being indicated in both the thermometers, then we will begin with our experiment. We'll allow the gas to pass to the burner and it will get ignited. After ignition, or for a specific time, the gases will be allowed to pass into the burner. So they'll get ignited. So after ignition, they're going to produce certain amount of energy and byproduct. Okay. So the energy, whatever heat is being produced, it is being taken up by the water which is being circulating throughout. Right. So heat will be absorbed by the water in the copper tubings. Okay. So there will be change in the temperature. So that will be indicated in the thermometer, right? So we'll do this process continuously for roughly 35 to 45 minutes, so that whatever heat is being generated here, it is being taken up by the thermometer, by the water, sorry, and it is being shown up by the thermometer. Okay, fine. Right. So we get two temperature, the inlet temperature and the outlet. That is the initial temperature and the final temperature. Fine. Okay. So after the combustion, there must be some byproducts uh, which would have been found, like produced, right? And acha, before this, gases are also being made up of n numbers of component. It may have smaller hydrocarbons, right? Carbon monoxide, H2, so many things it can have. If it has hydrocarbon, that is CH4 for example, so carbon will produce CO2 and hydrogen will produce water, right? So after the combustion of fuel here, some byproducts will be formed. So the gases byproducts like CO2, SO2, N2, we cannot cool them, right, here in this chamber. So they may leave, they can easily go out. But water vapors which has been formed here are being condensed. How it has been condensed? Because the water has been circulating into this inside the boy's calorimeter. So because of the continuous circulation of water, the water vapors get condensed, and that condensed water vapor is collected here in this tray. Fine. Okay. So what we are going to do is we are going to remove the water here, or it will get accumulated here as condensate, and we are going to weigh it. We're going to find out its mass. This is how the experiment basically works. Am I clear? Insulation करने की जरूरत क्या थी? So that there should not be any exchange of heat, either from outside to inside or from inside to outside. Am I clear? If yes, put yes in chat box. Yes, ma'am. Naved, thank you so very much. Anush Indurkar, yes. Zaid Sanika. Okay, thank you, Asher. Okay, thank you. Let us proceed further. So I hope the construction part is clear. With the construction, I have explained you the working also. Thank you, Afan. Thank you, Sumera, Tanushri. Thank you so much. Okay, let us proceed further. How the calculation part has been done. Working, I told you. The gas, this is what simple language में मैंने यहाँ लिखा है. The gas has been turned on, it is ignited. Water is turned on and the rate of flow is so adjusted that the rise in the temperature of water is passing through the calorimeter is about 20 degrees Celsius. After 45 minutes, the following readings have been noted down. Okay? कौन कौन सी रीडिंग नोट करना है, कुछ तो हमें पता ही है और कुछ हम देखते हैं कौन सी. Let us see what we need to jot down. We are going to jot down first the volume of the gas burnt at a given temperature and pressure during a certain time interval, that is T. है ना? कितना रहेगा V volume. Okay. Next is the amount of water passed through the coil during the same time interval, that is small t. Both the t's are same, हाँ? कितने समय के लिए हमने पास किया था. So let the amount of water be small w. Temperature of incoming water is T1 degree Celsius, जो कि कम होगा. Temperature of outgoing water T2 degree Celsius, जो कि ज़्यादा होगा because हमने T2 कब पता किए थे, जब combustion हो गया था fuel का. Sorry. And let us find out the amount of water which has been condensed during the experiment, that is M. This is the water which has been collected in the tray in the form of condensate. Okay. Now let us go with the calculation part. We know that GCV is being given, or we assume that let the GCV be theta. So total heat liberated will be what? जितना volume था, जितना वॉल्यूम को हमने बर्न किया था, मल्टीप्लाइड बाय थीटा. सो टोटल हीट लिबरेटेड इज V इंटू थीटा. अब लिबरेशन हुआ है तो अब्जॉर्प्शन भी होगा. तो टोटल हीट अब्जॉर्ब्ड इज W इंटू T2 माइनस T1. What is W? W is the amount of water which was been flowing into the boy's calorimeter. Clear? Now we know that heat liberated is equals to heat absorbed. जितना दिया था उतना absorb हुआ है. So let us write both the equation. V theta is equals to W into T2 minus T1. Next step, we'll keep the theta here and we are going to remove V to the other side. Then GCV becomes theta is equals to W into T2 minus T1 upon V. So if you wanted to find out the gross calorific value of a gaseous fuel and a liquid volatile fuel, then you are going to use this equation. Which one? Theta equals to W into T2 minus T upon V. It is having the same notation. The notations remains same. Okay. Any doubt here? Any question? No doubt, no question. Shall I proceed further? Voice may be breaking because of the internet connectivity or issue. I've been using a broadband line. So maybe because of the connectivity, voice may be breaking. Vineet is saying he didn't understood. What do you, क्या नहीं समझा? What you didn't got? विनीत, I suppose आप पहले से नहीं थे, अभी अभी ज्वाइन किए हैं आपने. Maybe please just rewatch the video. Hope the things will be clear to you. T2 minus T1 इसलिए किया है because we need to find out the change in the temperature. Change in temperature अगर मैं पता करना है तो वो T2 minus T1 ही होगा. तो it is बड़ा, T2 will be हमेशा higher side. T1 is nothing but the normal room temperature. So after burning, whatever heat was being produced, it is being taken up by the water. तो T2 हमेशा बड़ा रहेगा, इसलिए नेगेटिव में आंसर ना आए. Henceforth we are doing T2 minus T1. Okay. Fine. So we have found out what is GCV now. Now let us go with, अब GCV तो हमने पता कर ही लिया है, अभी हमें पता करना है NCV कैसे निकालते हैं. Okay. So we know the amount of water which has been condensed by 1 cubic meter of gas is M upon V. ठीक है. And the latent heat of steam per cubic meter of gas at normal temperature, that is 15 degrees Celsius, is 587 kilocalories. Therefore, NCV will be equal to theta. Theta is nothing but GCV minus M upon V into 587. M upon V into 587. So today I have given you two more formula for GCV and NCV. ठीक है, GCV भी मिल गया हमको, NCV भी मिल गया. And with these formula we can easily find out the gross and the net calorific value of any gaseous fuel or liquid volatile fuel. Am I clear? Yes. So that is what was being planned by me for today's lecture. For reference, I am been using Engineering Chemistry by S.S. Dara and Engineering Chemistry by Jain and Jain. The next class, I will be teaching you the numericals on GCV with respect to bomb and boys calorimeter. So for the next class, it's a it's a request to all the students to kindly sit with scientific calculator so that I'll be doing one numerical here with you live, and the other numericals will be given to you as homework. Okay. Thank you so very much. That's all we have for today's lecture. Hope to see you in the next class. Okay. And requesting you to kindly give your attendance on WhatsApp through Google Form. Link I'm been sharing on WhatsApp. Okay. So thank you so much. Stay safe, stay blessed, take care of yourself and as well as your family. Thank you. God bless you.